So we're starting piecewise functions now, and the piecewise function is kind of what it sounds like. You have multiple pieces of uh, different equations in the same function. So in this first example, there's two pieces to it. So you have this first piece, and then you have a second piece. So the idea is just to graph both pieces, and the domain that they list over here tells you where to graph each piece. So the first piece is graphed where x is less than negative 2. So if you go to where x is equal to negative 2, right there, that's going to be a boundary line. So if I put a vertical dashed line through there, I know that the first function that I circled in red will be graphed on the left-hand side of it, and the second function will be graphed on the right-hand side of it. Okay, so let's go ahead and graph it. So this first function is just y equals x plus 5. So it's just a linear function. So you go up to where the y-axis is 5. That should be, right? Y equals mx plus b. Remind you of that there. Y equals mx plus b. So the b is 5, so you go up 5. 1, 2, 3, 4, 5. Put a dot. And then your slope is 1. So you'd go up 1 and right 1. But we said that this red function needs to be on the left-hand side, so I don't want to go up and right. I want to go down and left. And then that's where I'm going to graph my function. Now on the boundary line, this dot should be an open circle because it's not equal to the boundary line. So I'm going to erase that dot there and put an open circle there. And then I only want this to exist on the left-hand side, so that's where I'm going to draw my line. Okay, so there I've graphed the first function. And the second one is just y equals negative 2x minus 1. So I'm going to graph that like a regular line. So I start at negative 1, and then I do my slope, negative 2. So I'm going to go down 2 and right 1, down 2 and right 1. Now I want to get the dots up to the boundary line. So I'm going to go left, so up 2 and left 1. And then up 2 and left 1. That's going to hit where I have that open circle, which essentially just fills that circle in. Okay, so then I'm not going to go past the boundary line because it doesn't exist over there. So I start at the boundary line and then I go to the right of it. Okay, and there I have graphed both pieces of this function. Now I'm using the word function, but really I guess we don't know if it's a function or not until we have it graphed. But is this a function? Is there any overlap? Okay, it says identify whether or not the graph is a function. Does it pass the vertical line test? So is there any vertical line that hits the graph twice? And there, obviously one line is going to be a function. So the only spot in this one that's any question is the where they meet. But since they're hitting the same point, one's open and one's closed, then it is a function. Okay, so yes, it is a function. Okay, and then it says evaluate the graph at any specified domain value. Okay, so these are the specified domain values. So we want to evaluate each of those. So when x is 3, what's the function equal is the question. So you go over to where x equals 3, 1, 2, 3, and then you go down. What's the function going to equal? Well, I didn't continue that slope all the way, but I could just go down 2 and right 1 more. And so the function is going to equal this value here. So that would be negative 1, 2, 3, 4, 5, 6, 7. So this is equal to negative 7. F of negative 4, so you go left 4, 1, 2, 3, 4, and then go to the function, and that would be the function's value. So that would be up 1, so positive 1. Then f of negative 2, go left 2, left 2, that's the boundary line, right? So the boundary line gives us the blue function, which either way it's the same thing, so its function's value would be 3. Okay, so that's the idea. You graph both pieces on whichever side of the boundary it tells you to be on. Okay, so the second one, the boundary would be x equals 1. So go to that x equals 1, draw a vertical line. And this first function says x is bigger than 1, so this is going to be on the right side of the boundary, and this one's going to be on the left, because it says x is negative 1. So you just graph each of those in the correct place, and then you'll be fine. The fourth one here has 3 pieces, so you'll have 2 boundary lines and 3 different sections. So the first boundary line would be where x equals 0. That's the y-axis. So draw a vertical line on the y-axis, dashed line. And then the next boundary line would be x equals 5. So 1, 2, 3, 4, 5. Draw your other boundary line. Okay, so x is less than 0. That's what the first one says. X is less than 0, so that's going to be to the left. This one is going to be in the middle. It says x is between 0 and 5. And then the last one is going to be to the right. Okay, so you just graph each of those. Remember, y equals 2 is just a horizontal line through y equals 2.